Hello, this is the lecture for linear inequalities in one variable. Solving inequalities is very similar to solving equalities. Equalities, of course, are algebra statements with an equal sign. Inequalities are algebra statements with an inequality sign, a greater than or a less than, or a greater than or equal to, or a less than or equal to. Okay, to solve the inequality, we're looking for the value or values. In this case, it's always going to be more than one value, the values that make the inequality true. Okay, the main difference in solving an inequality and solving an equality is if we multiply or divide by a negative number, we need to flip the inequality sign. Okay, when we write the solution to linear inequalities, it's always going to be more than one value. It's going to be an interval of values. So we may write the solution as an inequality itself, or we may write the solution set as an interval notation. Graphically, the solution to an inequality would be a sketch on the note line. Let's look at some examples. In this first example, 2x minus 7 is greater than 1. To solve this inequality, we want to isolate x by itself on one side of the inequality. All right, so we'll start. We've got a negative 7 there with the term with the x in it. We want that to go over to the other side. So we'll start by adding 7 to both sides of the inequality. So now we have 2x, these 7's add out. 2x is greater than 1 plus 7, or 8. Okay, to finish solving this inequality, we need to divide both sides by 2, because we don't want 2x, we just want x. So then we have x is greater than 8 divided by 2, which is 4. All right, this is the solution to this inequality in inequality form, right? Written as an inequality. So any value greater than 4 is going to make that original inequality true. Okay, we could test that with a few values. Say x was 5. 2 times 5, that's 10, minus 7, that's 3. And 3 is definitely greater than 1. All right, the instructions here are also asking us not only to write the solution set as an inequality, that's this one here, that's the inequality, but also to graph that solution set and then write that solution as an interval. All right, the graph of x is greater than 4. It'll look like this. We'll say 4 is right here. So the graph is going to be all values greater than 4, but it's greater than or equal to, so we need to use the open circle. So that pink line there is the graph of x is greater than 4. Okay, and then we also want to write the solution set as an interval. In interval notation, this solution would be written as 4 to infinity. Infinity always gets that parenthesis by it. And the 4, it's not greater than or equal to 4. So this is an open interval. We need to exclude that actual value of 4. So we'll use a parenthesis next to the 4. Okay, so we have the inequality solution. We have the graph. And we have the interval notation for the solution, or the interval. Let's look at this second example over here. So we've got a little bit more going on, but we have the same objective. We need to isolate the variable by itself on one side of the inequality. All right, so we have an x term on the left. We also have an x term on the right. We're going to need to move one of those terms over so the x terms are together, right? So I think I'll just go ahead and add 2x to both sides. And then at the same time, I know I'm going to need that 3 over there with the other constant. So at the same time, I think I'll subtract 3. from both sides. So negative 5x plus 2x is negative 3x. The 3's add out. That's going to be less than or equal to 6 minus 3. Of course, is 3, and the negative 2x and the positive 2x add out. Okay, my last step here is to divide both sides by negative 3, so that all I have left on the left-hand side is that x. I'll divide out, right? But here's the one difference between solving inequalities and equalities. Since I'm dividing by a negative number here, I need to flip that inequality sign. So x is not going to be less than or equal to. Now we're going to flip it. It's going to be greater than or equal to 3 divided by negative 3, which is negative 1. Okay. So that is an inequality. However, we usually write inequalities smallest to largest. We usually do that. This is fine like this, that x is greater than or equal to negative 1. There's our inequality notation. Let's graph that. We'll say negative 1 is right there. X is greater than or equal to negative 1. That's going to be all the values greater than negative 1. But since it's or equal to, I want a closed-in circle here because I want to indicate that I'm including the negative 1 in the solution. Because x could be equal to negative 1. Right? My interval notation for this is going to be negative 1 to infinity, always a parenthesis by infinity. But since this negative 1 can be included, it's a closed interval compared to this open interval. I don't want to put a parenthesis by the negative 1. I want the square bracket, which indicates a closed interval on this end. All right. Let's look at a couple more examples. I have a little bit more to them maybe. In this first example on the left here, we need to simplify the right-hand side of this equation before we start moving things around, right? Or we need to distribute this negative 3. So when we distribute that negative 3 times 5 is negative 15. And negative 3 times 7x is negative 21x. Okay, we'll break down the 30 minus 6x. We didn't do anything to that side. Okay, now we can solve this inequality in a similar manner to the last one we solved. I think I'm going to go ahead and put the x terms on the left. So I'm going to add 21x to both sides. And we'll get the constants on the right, so I'll subtract 30 from both sides. Okay, these 30's add out here, and negative 6x plus 21x is going to be 15x. That's going to be less than negative 15 and negative 30. That's negative 45, and the 21x's add out. Okay, last step. Divide both sides by 15 so that I only have x left remaining on the left-hand side. Divide out. So my inequality solution is x is less than negative 45 divided by 15. That's going to be negative 3. Okay, the graph of this is going to look like this. And we'll say negative 3 is right there. So I'm interested here, x can take on the value of everything that's less than negative 3. So that's off to the left in the negative direction. Okay, but it can't be equal to negative 3. It's only less than negative 3, not less than or equal to. We do not have that line under there. So this is an open interval, and I need to use an open circle. The interval notation, of course, the lower boundary here is negative infinity because there isn't one. The upper boundary is negative 3, but it is an open interval, so I'll use the parenthesis next to it. Try this one on your own. Pause the video if you like. See if you can do it. to get x is less than or equal to -2, here's the graph, and then the interval would be -∞ to 2 with the square bracket. Let's see. I'm going to save this stuff. Sometimes we have compound inequalities, or you can think about this as two inequalities merged into one statement. To solve a compound inequality, one way to do it is by simply solving both inequalities at the same time. So if we look at this example on the left here, 1 is less than 3x plus 7 is less than or equal to 22. Our objective here is not to get x alone on one side of an inequality, but to get x all by itself in the middle of an inequality, right? So whatever we do in the middle between the two inequality signs, we want to make sure we do it on both ends as well, all right? So if my objective is to get the x by itself, I'm going to need to get this constant out of here. So I'm going to subtract a 7 from the middle, but I'm also going to subtract a 7 from the right side and from the left side. So 1 minus 7 is going to be -6. That's less than 3x, these 7's add out, right? Which is less than or equal to 22 minus 7, that's 15. All right. Now I'll need to divide by 3 in order to get x by itself in the middle. So those 3's would divide out, right? And since I'm dividing the middle portion of the inequality, I want to divide the two ends as well. Oops, that's not -3, that's +3. We're dividing by +3. All right, -6 divided by +3, that's -2. So -2 is less than x, which is less than or equal to 15 divided by 3, that's 5. All right? There's the solution as an inequality. Let's graph that. Heck of it. Doesn't say we need to, but let's do it. When we graph this, the values that x can take on are in between -2 and 5. So we'll say -2 is here. We'll say 5 is over here. So the solution is going to be all the values in between -2 and 5. It can be equal to 5, though. X is less than or equal to 5, right? So we want a closed interval at the 5. Closed in dot there. We want an open interval by the 2, though, -2, because -2 is less than x, not less than or equal to. So we'll put the open circle there. All right, written in interval notation. This is going to be -2 to 5. We want the parenthesis with the open circle and a square bracket at the closed end of the closed circle. Okay, let's one more. Let's do this one together. Well, we want to get the x in the middle by itself, so we need to get that 3 out of there. Let's subtract a 3 from all segments of this inequality. 1 minus 3 is -2. Bring down that less than or equal to. Bring down that -2x. These 3's add out. And bring down the less than sign. And then 15 minus 3 is 12. All right. Now we're going to need to get x by itself. We need to divide everything by -2. But since we are dividing by a negative number, remember with inequalities, if we divide or multiply by a negative number, which we are doing, we want to flip that inequality sign. We want to flip it. Okay, so this then is -2 divided by -2. That's +1. That's going to be greater than or equal to when we flip that sign. These -2's divide out x, which is going to be greater than, we're flipping that one as well, -6. 12 divided by -2 is -6. All right. Now we usually write inequalities smallest to largest, especially when we have a compound inequality like this. So this -6 is smaller than the 1, so I should reverse this. I should say -6 x and 1. But look, the -6 is less than the x. It's less than the x. So I want a less than sign in there. And the 1 is greater than or equal to the x, right? So I want to say a less than or equal to there as well. All right. When I reverse the order of these inequalities, I need to flip these signs back again. All right, so there's the inequality solution. -6 is less than x is less than or equal to 1. Let's graph that. -6 is there and 1 is there. The values that x can take on to make this inequality true are everything in between -6 and 1. We want an open interval at the -6, a closed interval at the 1. Oops. Closed in circle there. Okay, and in interval notation, -6 to 1, to +1, those are our solutions. Open at -6, closed at 1. All right, so there we have solving inequalities. It's just like solving equalities unless you need to divide or multiply by a negative number. If you divide or multiply by a negative number, you need to flip those inequality signs. If you end up, and when you're doing compound inequalities, the easiest way to do this is just to, whatever you do to get the variable in the middle by itself, make sure you do it on both ends as well. And then same rules apply with multiplying or dividing by a negative, flip the inequality. And then if your solution ends up greatest to smallest, you're going to want to rearrange that, right? Because we want to write inequalities from the smallest to the greatest, all right? So we would flip that around. We would need to flip those inequalities back. Okay. So there we have solving inequalities. Let's take a look at a couple of applications before we end this lecture. Let's see what's going on here. A local salesman receives a base salary of $1,500 a month. All right. He also receives commission of 8% on all sales over $500. All right, so the first $500 that he's in whatever he's selling, the first $500 worth of products, he doesn't get any commission on that. But if he sells more than $500, then he earns 8% of whatever those sales are. All right, he has a goal to have his monthly income at least $2,500. All right, so that's what's going on there. The first part A, says to write an inequality we can use to solve for how much the salesman will have to sell each month to reach his goal. All right, so we're going to solve for what? We're solving for how much he's going to have to sell. Sounds like that needs to be our variable, right? So let's assign the variable there. That's what we're looking for, how much he will have to sell. So I'll just write it here, and we'll just use x. Let x equal sales quantity, I guess we'll say. All right, so let's think about how can we write this English sentences as an algebra statement. We want it to be an inequality because he can certainly make more than $2,500. He'd be happy with the extra money, but he needs to make at least $2,500. All right, well, let's think about how his income is made up. He gets that $1,500 a month, even if he's sick all month and sells nothing, right? So let's start with that. We know he's going to get that $1,500, but then he's going to get some commission too, assuming he sells more than $500. All right, it's 8%. How do we find 8% of something? Well, when we have a percentage, we have to move the decimal over 2 places. So 8% would be 0.08 when we're multiplying to find a percentage. So 8% of his sales but we only want the sales to be over $500. Well, we said X was going to be our sales quantity, so his commission then, it's going to be 8% or 0.08 of his sales, but he doesn't get paid on the first 500, so it's going to be his sales quantity minus 500. I got to take that 500 out of that commission calculation there. He doesn't earn commission on that first 500, or she doesn't earn commission on that first 500. So that looks to me like a pretty good formula for calculating the income for this particular salesman. Oh, it does say salesman, not salesperson. So I guess it is a man. Now, what we want our inequality to do is to find out how much he needs to sell, X, to reach his goal. His goal needs to be at least 2,500. Okay, so that 2,500 needs to be less than or equal to the income calculation. So there's our inequality. 2,500 is less than or equal to 1,500 plus 0.08 times X minus 500. I could have written that the other way too. I could have said the income calculation, the 1,500 plus 0.08 times X minus 500. I could have said that that has to be greater than or equal to 2,500. Either one of these is correct. With an inequality, you can write it either way. All right, so now in part B, we want to use this inequality to find the minimum amount a salesman has to sell each month to reach his goal. All right, so what we're doing here now is we're solving for that X, right? That's the sales quantity, the minimum sales quantity to meet that goal. So, well, I guess I'll use the first version of my inequality. Doesn't matter, but I think I'll use that one since I wrote that one first. So 2,500 is less than or equal to 1,500 plus 0.08 times X minus 500. All right. Well, I think I want to distribute that 0.08 first. Simplify this a little bit, right? Let's distribute that 0.08 so I don't have to have parentheses. So then 2,500 is going to be less than or equal to 1,500 plus 0.08x minus 0.08 times 500. Oh, I don't want to do that in my head. Let's use a calculator. Oops, I divided. Let's try it again. Clear, clear, clear. Okay, 0.08 times 500. 40. There. All right, so we need to get X by itself. Here's my X term. Well, let's combine like terms first. We'll combine that 1,500 and that negative 40. All right, so then we have 2,500 is less than or equal to 1,500 minus 40. So is that 1,460 plus 0.08x. Okay, and maybe we'll just leave X over here on the right and move that 1,460 to the left. So let's subtract 1,460 from both sides. Kind of running out of room, so I think I'll go up here to finish it. So 2,500 minus 1,460 is 1,040. So 1,040, please guys add out, is less than or equal to 0.08x. Let's divide both sides by that 0.08. We'll have our answer. Okay, so 1,040 divided by 0.08 is 13,000. So 13,000 has to be less than or equal to X, or I could also say X has to be greater than or equal to 13,000. Probably the better way to write that. So if he sells more than $13,000 each month, he will reach his goal. Let's look at another. Let's look at one more application. I'll get the page separated. I think I have another one here. I do. This is one you might be able to relate to. Harry has received scores of 72 and 78 on his first two 100-point tests. Okay, what score must he get on his third 100-point test to have an average of 80 or greater? All right, so let's think about what's going on here. So if he's got a 100-point test and he scored a 72 on it, that's like 72%, right? Okay, so that's how that works. 78 out of 100, all right. That makes sense. Now, what is an average? Well, with an average, to find the average, we add up all of the items and divide by how many there are, right? So if I wanted to average these three tests, I'd have to add the scores, 72 plus 78 plus, well, I don't know what that third test is going to be yet, right? So we'll make that X. So there's my three tests. When I divide them by 3, that gives me the average. That gives me the average. And the average has to be 80 or greater, right? So this average has to be 80 or greater. That would be a greater than or equal to 80. Okay, now we've got our inequality. We'll just solve for X. Well, let's simplify it a little bit first. I've got like terms that I can combine here and here. 72 plus 78 is 150. So let me simplify that. 150 plus X divided by 3 is greater than or equal to 80. Okay. Solving for X, well, let's see. I want to get that 3 out of the denominator. So let's multiply both sides of this inequality by 3. And those 3's will divide out. So 150 plus X then is going to be greater than or equal to 3 times 80, or 240. Okay, we don't want 150, we want just the X here, so let's subtract that 150 from both sides. Oops, that's supposed to be 150. So then we see that X has to be greater than or equal to 240 minus 150 is 90. All right, so there it is. He needs 90, not 99. He needs to score greater than 90 on that third test. And this ends the lecture. This ends the lecture for inequalities in one variable.